Okay, good afternoon, ladies and gentlemen. Welcome to the Chairman's Keynote. I'm Mike Ferguson, your conference chairman. Have you all been enjoying the show? Great. It's been a fantastic couple of days. Thanks for all of you for coming. My topic today is really to look at the whole, let's say, approach, software development approach that seems to be disrupting what I would call the traditional ways in which data warehouses have been built in previous years, bearing in mind we're, 30 years or more into data warehousing these days. And also how machine learning has kind of, in a way, with the whole Python age or Scala or R or on rare occasions Java, people building pipelines with code and notebooks and things like that has kind of driven a more software development approach towards machine learning model development, and that's also impeded or pushed in on the traditional data warehousing world. So what I want to do is talk to you about, look quickly at the traditional approach to data warehousing development, look at the emergence of the whole software engineering practices that have been perfected over the last several years when building applications, or indeed in building software products. And then look at what that's doing to data and analytics development. And then say, okay, well then what are the challenges if we're going to go build these kind of analytical systems using this kind of an approach? And what are the kind of requirements that would speed up the overall development from end to end and take us into kind of next generational approaches to building these kind of systems? And how should we think about component-based development of analytical systems, whether that's to help you build pipelines for training machine learning models and deploying those, or whether it's for building data warehouses, or indeed lake houses, or indeed graph databases, or anything else for that matter. So if I just look at the traditional approach, I mean, it's been pretty stable for a very long time now. The ability to just build ETL tools, ingest data into staging tables, switch to ELT, and use the power of SQL in a database to transform data into production tables, maybe take subsets down into data marts. That's been going on for forever. And it's often been IT-driven, centrally based, rather than any specific areas in the business. And over the last several years, we've seen the convergence of data lakes and data warehouses, trying to bring the worlds of business intelligence and business analysts on the one side together with machine learning and data scientists on the other, so that the output of machine learning becomes the input to business analysts, so I can get things like predictive insights into my BI reports and things like that. And starting to take things like ELT processing and say, well, could we push that down into more scalable cloud storage and process the data down there, and then even access that data through external tables from data warehouses, or have some of the data in a data warehousing system per se, and some of the data not. But this whole initiative has been going for quite some time. But what's happened in the world of software development is really impacting data and analytics today. And we know that software development has gone from building monolithic applications towards building microservices, and the advantage of that is several-fold. Yeah, I can build individual microservices independently, I can test them independently, I can even scale them independently, I can maintain them, I can replace them without impacting other parts of an application, and I can add new functionality that way without disrupting any of the other parts of the application. And so what we've seen more and more is that the speed of being able to get a new release of an application out or a new release of a software product has just come down and down and down and down. Today, where are we getting into anytime there's any update, it triggers automatic build, automatic test, automatic deploy, if you pass all the tests, and so we're just getting faster and faster and faster in rolling out applications. And so people are saying, well, hold on a second, that's really valuable. Why can't we do that to speed up the development of analytical systems? And so we're now seeing these kind of practices, component-based development, pushing in on let's use this for data warehousing, or let's build it for lake houses, or whatever combination you've chosen. And you can see that in the tools. I mean, data modeling tools can now check code into Git. I mean, so this is Irwin, for example. So if I build a data model and I want to physically deploy a physical model, the code that's generated by the modeling tool can itself then be versioned and managed in a kind of DataOps, DevOps kind of way. Not only that, but I can do the same in data fabric software and several ETL tools as well, but data fabric software like Azure Data Factory or IBM's Cloud Pak for Data or Google's Dataplex. I mean, all of these are now integrating with Git to allow collaborative development, so multiple people can get involved in building a single pipeline and build different individual components of it, and you can control that, version it, and bring it together into a new release of a pipeline and get collaborative development. If you don't want to go data fabric and buy best of breed tools, transformational tools like DBT, for example, same thing there. Again, I get SQL models, which are transformations done in SQL. I can build up several of those components, string them together. I can check the whole thing into Git and manage automatic build, automatic test, automatic deploy in those kinds of tools as well. If I go to BI tools, Google Looker with the modeling language allows me now to build semantic layer modeling components. So I can have multiple people working on different components of a semantic layer, and I can check all of that into Git. So now I've got modeling tools, I've got data fabric, I've got transformation tools, I've even got administration stuff on databases going in there. I've got BI tools going in there, and I've also got data science tools, which probably were the first type of tooling, if you like, in data and analytics to adopt the whole DevOps or kind of data ops approaches. So what we're now seeing is pretty well every kind of tool that is being used in building analytical systems, whether that's to build machine learning models in data science or whether you're building data warehouses, are all now have the capability to support version control in a common place, to do automatic build, automatic test, automatic deploy, but more importantly, they can fuel collaborative development so that different team members, whether they're co-located or not, can work on multiple components that can then be assembled to create what you're trying to build. And so these sprints can emerge. And now what we see is the same things happening with data. So we're not building a single monolithic data model anymore for a single system, like a data warehouse or to build a single machine learning model or even a graph database. What we're now building are data products. And I mean, you must have been inundated with data products here at the show. I mean, everybody's talking about it. We've had a data mesh data. We've had Jean-Marc Degani do the keynote here. It's data product mania, right? And people now looking at, well, okay, we are decentralizing the development of data products out into the business, which has a massive impact on IT, which I said yesterday when I opened the show, because we've got to push expertise into those business teams to upskill them and get best practices in there and enable them. I liked what Karthik Ravindran said at Microsoft in his keynote in this theater earlier today. He didn't call it a center of excellence, absolutely not. He called it a center of enablement, to enable different parts of the business to go and build data products and build the pipelines that would produce that. But the pipelines themselves are not built by a single person anymore, a single data engineer. We now got collaborative development of pipelines. So you kind of then look at this traditional approach and you think, well, how on earth do we adopt these practices that are really reducing development times into traditional data warehouses? And what kind of challenges are we dealing with? Well, the challenges that we have here is that data is now complex. The data estate is not centralized, it's distributed. We've got data in software as a service apps. We've got data in multiple clouds, in various kinds of systems, transaction systems. We've got data on premises. We've got data at the edge. So the data landscape is highly distributed, and more data sources are piling in and making that even more challenging. Which is why, by the way, the data governance theater, I don't know if you looked at it, has been stacked out all the last couple of days as people struggle with this kind of complexity. Because it's hard to find data, and you're trying to shorten the time to development, and yet data is getting progressively more complicated. It's a big conundrum. And so how do you deal with that? Not only that, but the way we've been building analytical systems so far has been fairly siloed. You know, we've got our data warehouse, or maybe you've got multiple data warehouses. You've got cloud storage, and you've got machine learning all happening over there. You've got maybe a graph database or something like that for fraud or something. You know, it's a niche area of analytics, separate kind of NoSQL database. I may be doing time series, you know, real-time streaming analytics, you know, in order to do some kind of real-time fraud detection or IoT analysis of production lines in a manufacturing plant to do predictive maintenance and be able to keep those machines running optimally. But all of these things have all been run as silos. And what's ironic about it is you see different data integration tools in each silo, so different people using different tools to do the same thing. And what's worse is they are often taking the same data from the same sources in many cases, or there's some degree of overlap. And so the reinvention is kind of crazy. And you can't share metadata across tools, so people, because there's no standard, and people can't see that others are already doing stuff that they need because they haven't got access to the metadata in other tools. And the last thing we want is, if we go down to component-based development, is this. We do not want chaos. We've been through that. If you remember back to 2013, 2014, when we saw the emergence of self-service BI, everybody got their own self-service data prep tools, and it was a wild west, right? And we just do not want that. We've got to learn from our experiences. So if we're going to democratize data engineering and get multiple developers, multiple citizen developers building pipelines, we do not want this. And the other problem, if you have best-of-breed tools, is there's overlap between the tools and some of the functionality. And you don't want competition breaking out, different teams saying, well, we're using our tool, we're using your tool, and that kind of thing. We also don't want tools that don't work together. We want them to integrate and share things. And we want to make sure that people are not building components that just don't plug into anything else. So this is quite a challenge. It's actually more of an organizational challenge than it is necessarily a technology challenge, which I think is why I liked what Karthik Ravindaran said, an enablement, a center of enablement. But the point is this: we do not want the picture on the left. And I think a lot of the time in the past, we've been with a fractured approach, and we've been building data that way. You know, it's all fractured. There's people working on all kinds of different tools around the enterprise. What we really want is findable, trusted, compliant data products and all of the analytical products like machine learning models and reports and dashboards and all those kinds of things, all organized and aligned to improve business outcomes. So if that's the challenge, then what kind of requirements do we need to be able to speed this up? Well, we've got to industrialize. And that requires some degree of organization. I mean, if there's different teams around the organization, or multiple developers building a pipeline, multiple citizen developers building a pipeline, we've got to, if we want to industrialize this, you have to take complexity away. You've got to make it easier for them to do things. You don't want them struggling with all kinds of infrastructure stuff. We've got to take the complexity away to allow them to do it. We've got to standardize on certain things so that people are not building components where there's friction and they can't work together. We've got to be able to make sure that what we're building is going to fit together like pieces in a jigsaw puzzle. So industrializing this to speed up the development is kind of important. And the idea is that data products are incrementally allowing us to build ready-made data. But if you're going to build ready-made data, I absolutely need to think about how are those data products going to work together if I need to pick several of them. If you go to a canteen for lunch, you don't expect to go into, you go into a canteen, expect to look what you want to eat, and you pick and choose what you want, and you go and eat it. But, if one of those products or food products, as you see here, was sitting there, if it had been there for 30 days, would you eat it? Probably not, right? But the point about this is you need additional information to know that it's been there for 30 days. You need metadata supporting that to help people who want to consume this stuff know about what's been ready, put in front of them, what's ready-made. But quite clearly, master data products fit very well with business data concepts. Customers, product suppliers, transactional data products, orders, shipments, payments. These are quite easy to understand, and lots of people around the business will grasp that very, very easily. And there's a difference. There's so much confusion around what is a data product. I tend to get confused myself. So what I do is I say, I'm building data, but I'm also building analytical products. I think BI reports, machine learning models, prescriptive models, all of those are analytical products. Even plans looking out further into the future, AI-driven bots. Those are analytical products which have been built using data products. And so, to me, I could have physical data products, physical data sets. Like they could have virtual ones. See several vendors with the ability to create virtual data products. I noticed Starburst was showing that today on their stand. Vendors like Dremio and several others here, Data Virtuality, all of them, Denodo, all able to do this kind of stuff. But the point is that I think there's a difference. And if we want to go and build these things, then we need technology. And I think there's a couple of things we need. Remember, we said the data landscape is complex. We need data catalogs and a business glossary to understand the meaning of the data. In addition, we need some kind of data fabric software, or if you're going to go best of breed, like I said yesterday when I opened the show, you really do need to make sure that the best of breed tools you're choosing are going to work together. There really is integration to share things across those tools, because if you can't, then you're going to have people reinventing things in different tools. But certainly when we talk about data fabric software, I'm not talking about data fabric as an architecture. I think that's a wrong statement, in my opinion. Data fabric is software. These are software platforms that can connect to that distributed landscape and be able to access it. But within those platforms, I have the full capability, data modeling tool capability, where I can define common definitions also in business glossaries. So I can say, here's the common definitions for a data product. So I can have, here's the schema for a data product. I can have component-based pipelines to pull together the data from various parts of a distributed data estate. And I can orchestrate all of these to produce data products. And then I can control all of that by checking it into the likes of Git or GitHub, and full CI/CD capability to control automatic test, build, and deploy. And you can do that in a couple of ways. Obviously, the methodology is really about saying, well, we need to produce data products, and in order to do that, I need to have a business glossary component which describes the data product. So if my data product is customers, I need a set of definitions in my glossary that describes customers. If I need a schema for a data component, then I need to say, well, how does this schema look like? If I need a pipeline to build the data component, which is itself going to be component-based, all of that should be part of it. Then if I have these components and I build these data products, I need other pipelines that are going to consume those, and those pipelines themselves may be component-based. If we're going to visualize anything, component-based development of a semantic layer like we saw in the Google Looker example. And I need component-based pipelines to produce or to consume analytical products like machine learning models and use those, and even to drive automatic actions around the enterprise. So the point about this is there are producers and there are consumers. And there are multiple teams of producers, and it's collaborative development to go and build all of this stuff. But if I'm going to build all of this stuff, I have to publish it somewhere so everybody else knows what's available, what's ready-made, what's in the canteen. I need a marketplace. And we're seeing the growth and rise of marketplaces, several of which are available to view on the show floor this week. And then I've got a choice. Do I want to go and build it all with a common data fabric software, all of those components, multiple people working on a pipeline, all with the one platform? Or am I going to go best of breed? So if I look at the first of these, taking a single data fabric, the idea is we have multiple teams of data product producers sharing a common platform. We've got support by this kind of enablement, center of enablement, which is pushing expertise out into those teams to upskill them and take complexity away so that they can connect to the data across a distributed data estate and produce these data products, which will then be consumed or assembled into an analytical environment. We've got to define what the data products look like. We can't do that as IT professionals, and we don't want IT professionals to necessarily do that. We want the people who understand that data to do it, the subject matter experts in the business domains, to get together and define what is a customer, what is a product, what's an order, and create those common business terms in a business glossary, which these days you will find inside a data catalog. So a business glossary is not a separate software product, it's inside a data catalog. And then once I have these common definitions, we got to make sure that they use global identifiers. So that if I have an order which is being ordered by a customer, this customer has ordered these products, then an order data product needs to use identifiers of a customer and a product so that we can snap these things together. Global identifiers make data products look like Lego bricks, because if they're available and I can pick them off the shelf, I know they're going to snap together because they're using global identifiers. I need a data catalog to automatically discover the data across my distributed landscape, but it's more than that. I have to automatically data quality profile. Some of these catalogs do that today. Automatic data classification, several classification vendors. I noticed the classification guru's session, Susan Walsh, was absolutely stacked out. They couldn't get in the room to understand, to look at her session. But the idea with Data Fabric is I don't build pipelines to build one system. I build pipelines that build data products. And then I build consuming pipelines that take the data products and use them for different analytical use cases. You may do that on a single, you may do all of that on a all those use cases may happen on a single platform, but you may have graph database, you may have data warehouse, you may have data science wanting to use that. But the point is you build it once, and you take the definitions that are in your glossary, in your catalog, and you build a pipeline to produce the data product. And so it's build it once, reuse it everywhere, with global identifiers that allow us to do that. But the pipelines themselves are now a collaborative development process. So we can have multiple people working on building a pipeline to produce a data product. And to speed that up, of course we can go to component-based pipeline development. If you need to ingest a file, why does somebody have to figure that out? Why haven't I got an off-the-shelf component to do that? If I want to be able to transport data, why haven't I got a component to do that? If I need to mask data as part of a governance exercise, I should have a component to do that. These are all reusable things so that the people, the citizen developers building pipelines in the domains, they should have these off-the-shelf capabilities. Even if I have complex data, I should have the ability to take voice data, have a cognitive machine learning component, feed it voice data, it gives me back text. Or if I have text, feed it text data, it gives me back maybe structured data out of the text, or it gives me back scored sentiment, or whatever it does. But we can build a library of these components together. And the benefits of component-based pipeline development are not something that people would say are new. There's tons of articles about the benefits of component-based pipeline development, all the way back to the beginning of data warehousing on ETL tools. There's less to build because you've already got stuff that's available, that's already been built. There's standardization for doing things so that people don't have to figure out how to do stuff when there's a standard way within the organization to do it. You're just trying to accelerate the building of pipelines with these kind of approaches. And then obviously with CI/CD, I have the ability to test each of the output of each of the components. Maybe it's row counts, maybe it's looking at data to see if there's any errors in the data, and we've definitely seen data observability vendors helping people who build pipelines to quickly do those checks, automatically do those checks. Obviously, if the tests all pass, then it's automatic deployment within containers and automatic runtime configuration so that you can push it all out onto the likes of a Kubernetes environment to run on a cluster. Now, if you do it with best-of-breed tools, it's more challenging because we have to coordinate who's building what components with what tools in order to make sure that they're going to snap together. That's harder to do than if they're all sharing a common platform, because if they share a common platform, people can see what other people are building. It's also why I said yesterday that you need a program office to be able to support this. So if you did have multiple tools building components this way, you've got to make sure that organization is there so that you know that these pieces are going to fit together in a pipeline. And therefore that you do all check into GitHub, that you can do CI/CD, and you can build and deploy these in a similar fashion to what you would see built into Data Fabric software. So that you get this ability to coordinate development. But because of the fact that there is no metadata standards between tools, this is harder to achieve, because it requires all teams working on different tools to buy into the idea that they're building pieces of a jigsaw puzzle that will come together. It requires them to do that. To take I think Karthik referred to it as responsible, I can't remember what he called it, as responsible capabilities. But if you are using best of breed, there are also tools on the floor, one of them DataOps, for example, that can orchestrate pipelines with components built in multiple tools so that you can quickly build the data products that you're looking for. But once you have those data products, then obviously what I want to be able to do is publish them somewhere. A shop window, a marketplace. We're seeing a lot of these springing up. And of course, there are public marketplaces like the Snowflake one that Benoit Darganville was talking about on the Great Data Debate panel yesterday. Also, Databricks have got one of those, and several other vendors have got these public data marketplaces, but internal data marketplaces where you can publish the data products that you build on the marketplace for others to go into the canteen, so to speak, and see what's for dinner, right? I mean, they can see what's available. And then obviously what you want is for those to pick up those ready-made data products and start delivering new value with it, whether that's a new machine learning model, or it could be new BI reports, or whatever it is. Or even I can assemble a combination of these into a graph database, or assemble them into my warehouse, or bring them into my feature store to speed up development of all of these models. And if I then produce these BI reports and machine learning models and whatnot, or even new data products by combining others, I can then publish those back into the marketplace. And so what we're getting is incremental progression, so that it gets progressively faster and faster and faster, because what you end up with is more and more being built, more and more that's reusable, and therefore people looking to build new stuff should find 70%, 75%, 80% of what they need already made. So ultimately, you then end up with a foundation of trusted data products and trusted analytical products. and if they're all available in a marketplace, then we're in a position to say, okay, whatever part of the business you're in, whatever level you're at, whether you want to make decisions at operations level where there's thousands of decisions a day, or whether it's at the tactical level or even at the strategic level, what we can do is say, well, there's an alignment on strategy needed. We need to ensure that we reduce fraud. So which data products and machine learning models and BI reports and decision services are available to reduce fraud? So you can see it, and where are they deployed in the business to be able to do that? So that we get into this reusable set of components that we can quickly use in different parts of the business to deliver value fast, but also to ensure that they're contributing to common goals. So ultimately then we go into this kind of capability. We can discover data and catalog it. We can have people build single source data product, publish that. Other people take those, combine them, and publish that. Other people take combined data products, build machine learning models, and publish those. Other people then find machine learning models and go, I don't need to do anything. I'll just take this. And so you get progressively faster and faster and faster. So ultimately, ultimately what you end up with is progressively faster development. So I think all I would say is when it comes to component-based development of analytical systems, absolutely this is here to stay. But the biggest challenge for all of us is how do you organize this and get everybody aligned on common business strategy so that everybody knows which bit they're building and for what business purpose. And then I think you're likely to succeed. If we just say, give everybody tools, let them do what they want, you're going to get chaos. Okay, so I hope that's been of use, and thanks very much.